Hi, my name is Lisbeth Ramos, and today we're going to go over balancing chemical equations. So here I have two examples of different ways that this could be presented to you. So the first way we're going to go over is all of these words over here, because that is usually how you start off. So you are given the name of the molecule and you are to decipher this, create an equation, and then balance it. So let's do that one first. Over here, it says liquid pentane reacts with gaseous oxygen to form gaseous carbon dioxide and liquid water. So the first thing we need to know is find out what pentane is. So pentane is C5H12. So let's go ahead and write that down. And it says it's liquid, so its phase state is going to be L. That's a cursive L, just in case you guys can't see that. And it reacts with gaseous oxygen. So oxygen, when it's a gas in its natural state, is not just O, it's going to be O2. So that's thinking about your diatomic molecule. So remember to keep those in mind. And it says it yields gaseous carbon dioxide. So from what we know about naming, carbon dioxide, we know that's a covalent molecule. So there's one carbon, and di means two, so two oxygens. One carbon and two oxygens, and this is a gas. And then we have liquid water. Water is H2O, so we're going to go ahead and write that. And it's a liquid. All right. Now that we have our chemical equation, what I like to do is something that I like to call a grocery list. So I write out the atoms or the elements that I have on each side. So over here I have carbon, hydrogen, and oxygen. And I have the same thing on this side. Carbon, hydrogen, and oxygen. Now what I like to do is write how much I have on each side, kind of to see my inventory. So if I have more on one side, I know that I'm going to have to even it out by balancing the equation on the other side. So over here, I have 5 carbons, 12 hydrogens, and 2 oxygens. Over here, I have 1 carbon, 2 hydrogens, and here I have 2 oxygens plus 1, that makes 3 oxygens. So now you can see kind of where our differences lie. Every single element here has a different number on each side. That's where balancing the equation comes in. So the first thing I'm going to do is I'm going to balance out my carbons. And we do this by writing a coefficient in the front. You never want to change these numbers here, the little subscripts, because then you're changing the molecule. You don't want to change the molecule, you just want to change the amount of molecules that are present. So over here we have 5, over here we have 1. If I put a 5 out here, that means I'm multiplying every single element in there by 5. So then this turns into times 5, right? And that's going to give me 5. So those two now match up. Here, since I have 2 places where oxygen are present, I'm going to put those into 2 separate equations just so I can keep inventory of them. So now I have 5 times 2 plus 1, because I have 1 over here. And that gives me 10 plus 1 is 11. So right now I have 11 oxygens. Going back, I'm going to save my oxygens for last when I'm finishing balancing, because here it's only in 1 location while over here it's in 2. So if I change one molecule, like if I try to balance my oxygens over here, it's going to change my hydrogens and it'll never end. So we're going to go ahead and go on to hydrogen. Here I have 12 hydrogens. Here I have 2. So what can I multiply hydrogen by over here to make it equal to 12? So 2 times 6 is 12. So I'm going to write a 6 out over here. And that changes this to times 6 is equal to 12. So now my hydrogens are balanced. But it changes my number of oxygens as well. So I still have 5 times 2 over here, so that's 10. And now I've changed the oxygens over here, so 1 times 6 is 6. And now I have a total of 16 oxygens. So now I have to balance 2 and 16. So 2 times what equals 16? 8, right? So I'm going to go ahead and put an 8 out here. Times 8 is equal to 16. So now we can see that we have 5 carbons, 12 hydrogens, and 16 oxygens on both sides. So that means this equation is now balanced. It's not too bad, right? So another way that they can give you an equation or a question is like this. They already basically spelled it out for you. They already have the molecules. So I'm going to go ahead and start with our grocery list first. So over here we have cobalt, NO3, NH4, and sulfur. And over here we have the same exact things. So cobalt, NO3, NH4, and S. I like to keep them horizontally the same, even though they're not necessarily in the same order on both sides, just so that I can see easier which ones have the same numbers and which ones don't. So the reason I kept my atoms, my ions over here, my polyatomic ions, the same or together and didn't split them up into separate elements is because they stayed the same on both sides. NO3 is still NO3 over here, and NH4 is still NH4 over here. If NO3 were to change to NO2 for whatever reason, then you would have to split up these elements, but into their individual elements, okay? So then I would have to include nitrogen by itself and oxygen by itself. But since nitrates stayed nitrate and ammonia stayed ammonia, then we don't really have to worry about it for now. So over here I see that I have 1 cobalt, 3 nitrates. So notice that this is within a parenthesis. If it's within these parentheses, then this applies to the whole entire polyatomic ion over here. So that means if I were to split this up into its separate elements, I would have 3 times 3 is 9 oxygens and 3 nitrogens. Just keep that in the back of your head in case you ever need it. So now we have this guy over here. We have 2 of him and then 1 sulfur. Over here we have 2 cobalts, 1 nitrate, 1 ammonia, and 3 sulfurs. So now, as you can see, that when you're given the problem in this way, you don't have to decipher it. It's actually a step less that you have to do. So now we're going to see how we can balance this equation. So I see here that I have 1 cobalt and 2 cobalts on this side, so I can put a 2 out here in order to make it 2 and 2. However, when I change my cobalt, I also change my nitrates. So now this is also multiplied by 2, and that gives me 6. Alright, so another thing that I saw right off the bat that was different was that my sulfurs were different. So I'm going to do those next. So here I have 3, here I have 1. So if I multiply this by 3, then that will change this times 3 is equal to 3, alright? And then now I have 2 times 3 is 6. So luckily for us, these 2 guys are together and there's only 1, so all we have to do is put a 6 out front, which will distribute into everything, making everything 6. So now we can see that on both sides we have 2 cobalts, 2 nitrates, 2 cobalts, 6 nitrates, 6 ammonias, and 3 sulfurs. So now this equation is also balanced. And that's basically how you balance a chemical equation.